Hello, everyone, and welcome back. Today, we have started a new unit, and this unit is about proving triangles to be congruent. With this specific unit, we have a number of things that we need to talk about. The first being how we can prove that triangles are congruent. And then the second, proving different parts of triangles to be congruent. So this is just like the overview of everything that we're going to be doing. So I'm going to run through each of these things and talk about what they are and just kind of break down this unit for you and how we're going to do things. Okay, so we have 5 different ways to prove that triangles are congruent. And we call them SSS, SAS, ASA, AAS, and HL. And each one of these stands, it's a different acronym for how to prove. Okay, so what we're going to do first is we're going to write down what the letters stand for, and then we're going to talk about how they apply. Okay, so side is S, A is angle, and then we have H, which is the hypotenuse. So all of these are different parts of the triangle that we're going to be taking a look at. Okay, so that's what each one of these letters represents. Okay, so this first one here, SSS, what we have when we're proving this or proving triangles are congruent this way are 3 parts. Okay, 3 parts. Boy, sorry about that. I don't know what this thing is doing. I'm going to pause this and come right back, so hang tight. Okay, so we're back. I fixed the screen. Coming back here to SSS, we have 3 parts of congruent sides. So what that means is that on each triangle, there's going to be 3 pairs of congruent angles. Okay, so that's what I'm doing here is I'm just marking these triangles with the hash marks to show the 3 different sides that are congruent. Okay, so we have 1 pair here, another pair here, and another pair at the bottom. So that would be SSS if you have 3 sides that are congruent. The second way, SAS, is we have a pair of sides that are congruent, and then we have an angle, just 1 angle, not 2. We have 1 angle here, 1 angle here. They're corresponding, so they're going to be the same angle. And then we have another side, or another pair of sides that are congruent. Okay, so 2 sides and an included angle. Okay, included is kind of like connecting. So I'm going to write connecting here because the angle that connects these 2 sides together, talking about these 2, is included. So it connects, the angle connects the 2 sides together. Same thing on this one. This angle connects these 2 sides together. So SAS, you have side and then an angle that's in between the other side. Angle side angle is similar to side angle side, except this time you have 2 angles and the connecting piece is the side. So we'll say that we have these 2 angles that are congruent, and the other 2 angles are going to be here. You can choose. We could have chose to do these 2 up here, but I'm just going to do these 2 down here. Okay, so these are my 2 pairs of congruent angles, and then the congruent side connects these 2 angles together. So we have 2 angles that are connected by a side. So two pairs of congruent angles right here and here that are connected by these sides that are also congruent. Okay, this one here, angle side, we have two angles and then a side that is opposite of them. So if I went like this, these are my two angles that I know are congruent. So there and there. Okay, it's not going to be the one that's in between, right? Because we just had that. That was the included side. So there's two different places that a pair of sides could be. It could be either down here at the bottom, or it can be up here at the top. So it doesn't matter if you have them at the bottom or at the top. It can be either or. The key here is that we have angle, and then a side that is opposite of the two angles. So it can be either this side down here at the bottom or the one up here at the top. Okay, this HL, the hypotenuse leg, this one is very special because it only goes with right triangles. You can't use hypotenuse leg with any triangles, only the ones with the right triangles. Okay, so when we have hypotenuse leg, a hypotenuse, you remember that is the side that is across from the 90-degree angle. Okay, so up here where we have the hypotenuse, I'm just going to put that, again, the hypotenuse is across from the 90-degree angle. Hypotenuse is also the longest side. Okay, so there's two different ways that you could identify the hypotenuse. It's either across from the 90-degree angle or it's the longest side. It's both of these things. Okay, so with hypotenuse leg, we know that the hypotenuse are congruent, and then we could have any leg of the right triangle also be congruent. So it could either be this one going up and down or this one down here at the very bottom. Okay, now when proving these triangles congruent, okay, we have different reasons for sides and different reasons for angles. Okay, the one reason that both of these share are that it could be a given statement, right? So those are the easiest ones to identify when they give it to you. Okay, another reason that sides can be congruent are the definition of midpoint. Okay, and this right here tells you how a midpoint can be used. A midpoint will create two congruent sides. So if it tells you that, let's just say that point B is between A and C, okay, the midpoint creates two congruent sides. So that means between A and C, you have two congruent sides, which is AB and then B to C. Okay, so if we drew that picture, okay, this would be A. Just got to pretend that this is straight. It's hard to do it with this mouse. Okay, so point B. Okay, this would be our midpoint. Just like this. Okay, so point B would be the midpoint, and you'd have a congruent side here and here. All right, now the last one, reflexive property. This one is very special. Okay, the reflexive property, it tells us that a side is congruent to itself. So this is like when when two triangles share the same side. Okay, so I'm gonna write that down. Make sure that you get this copy down in your notebook. When two triangles, that's what we're trying to say. When two triangles share same side, that's when you would use the reflexive property. Okay, when two triangles share the same side. Okay, down here where we have reasons that angles can be congruent, okay, a lot of these reasons come from parallel lines, right? Okay, and even it tells you right here that if you're going to use one of these three reasons that are here in pink, okay, you must have parallel lines for these three: alternate interior, alternate exterior, and corresponding angles. Okay, we've talked about all of these, and these you can go back and look at the parallel line videos. Okay, and it talks about how these are parallel. It also includes an explanation of the vertical angles. Okay, but all of these angles that are listed here, these four sets of angles, these are all congruent. That means that they are the same angle measure. Okay. The last one, though, is this angle bisector. Okay, so angle bisector is similar to the definition of midpoint, except that an angle bisector will create two congruent angles. Okay, so angle bisector just splits an angle into two congruent parts, or two equal parts. Okay, this last piece, the CPC-TC, this is corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. We'll get to this at the end of this unit. Okay, but here, what we're talking about are these two congruent triangles. Triangle ABC is congruent to triangle DEF. And what we can do is we can write a few different things. We can write three sets of congruent sides, and we can write three sets of congruent angles. So if I do the congruent sides, okay, I'll do it on the picture first. Okay, we just go in order, right? So if I do the sides, I take positions 1, 2, and 3, and I just match them up to positions 1, 2, and 3 on the other triangle. Okay, so 1 and 2, that's AB. I'm just going to get that one congruent mark. And then 1 and 2 on the other triangle would be DE. The pictures aren't going to always look like this. Okay, sometimes they'll be flipped around. So you need to make sure that you get the right combination first, and then identify the right side. Okay, now I'm going to do 2 and 3, and those are going to get two hash marks. So BC would get 2 hash marks, and then 2 and 3 on the other one would be E to F, which also gets 2. That leaves position 1 and 3, 1, 2, 3, and position 1 and 3, which is DF, 1, 2, 3. Okay, so now when I write my congruency statements for the sides, I can say that segment AB is congruent to segment DE. We're just matching this up. Okay, you can do 2 and 3 next if you wanted. So that would be BC is congruent to 2 and 3 on the other, which is EF. Make sure that you put your segment on top. And then the last one would be AC is congruent to DF. Okay, so that would be all of the sides. When you do the angles, okay, you're just matching angle 1, which would be A, to angle 1 on the other, which would be D, and then B would get 2, E would get 2, and then C would get 3, 1, 2, 3. F would also get 3. So that one gets a little bit messy here on the picture. And then for these, you would want to make sure that you put your angle symbols. Angle A is congruent to angle D. Angle B is congruent. It's getting a little difficult to write here. Angle B is congruent to E. And then angle C is congruent to angle F. And then there you go. Okay, so this is just the opening video, the beginning video that introduces all these concepts. And we're going to get more into depth on each of these, and we'll go we'll go one by one, make a video for each one of these. So we're going to start off with SSS, move on to SAS, and then just keep working our way down the list, and we get to CPC-TC at the very end. Okay, so the next video, we will start talking about SSS and SAS, and I will see y'all in the next one.